Welcome to Aspire Test Prep's video on the basic rules of exponents and radicals. There's a worksheet that you can find at www.aspiretestprep.com that you can go to and go ahead and work out these problems on your own and then come back to this video for explanations on how to do the problems. Aspire Test Prep is a company offering online SAT, ACT tutoring for students and test prep classes for high schools. Our website is www.aspiretestprep.com and our phone number is on the screen. Starting with question number 1, if x is not equal to 0, what's the value of the given expression? This question is basically asking you to apply the order of operations, PEMDAS. Please excuse my dear Aunt Sally. And the order of operations basically says that you should be thinking about the parentheses and the exponents before you think about multiplication and division, and addition and subtraction, of course. But applicable to this situation, we want to go ahead and just basically use the exponents before we do anything else. So on this problem, we have the 3 that's already there, and we want to take that 3x and put it to the third power. So 3 to the third power is 27. And we have x to the third, and on the bottom we have x, and we also have 9 to the second power, which is 81 x squared. So the next step is on the top is to say that 3 times 27 is 81, and we have x to the third still, and on the bottom we have another 81, and x times x squared is also x to the third power. So we end up with a fraction that has the same thing on the top as it has on the bottom. So the 81s cancel with each other. X to the third cancels with x to the third, leaving only the invisible number 1. So the answer to question 1 is 1. Question 2. If we go ahead and do the exponents first, we have the 5 that was already there. Then we have 4 to the second power, which is 16, and x to the second power. And on the bottom, we have 2 to the second power, which is 4, and x squared, and not to forget the 2 that was already there. So on the top, we have 5 times 16, which is 80, x squared over 8x squared. And now we have x squared on the top and on the bottom. They cancel out, and 80 divided by 8 is 10. So the answer to number 2 is 10. Moving right along, if x is not equal to 0, what's the value of this expression? So on the top we have 8, then we can go ahead and do the exponent first. So 5 squared is 25, x squared, and on the bottom 10 squared, 100, and once again x squared. 8 times 25 is 200, and we have the x squared that's there, over 100x squared. So we have x squared on the top and on the bottom, those cancel. And 200 divided by 100 is the number 2. Going on to number 4, which of the following is equivalent to 4 to the 2/3? So what we want to know here is that if we have the b root of a to the c power, that translates over, if you put it into a fractional exponent, as a to the c over b power. So in our case, we have 4 to the 2/3, and that translates over to a base of 4. And what we want to notice is that the number that's on the top, the number that's in the exponent spot, stays on the top. So the number that's right here should be the number that's in the exponent spot. So for 4 to the 2/3 power, that means that the 2 is going to go right there, and the 3 is going to be the other number that goes in the index of the radical. So right now we have the cube root of 4 squared, but we'll notice that that doesn't match any of the answers, and the reason is because we can take that 4 and we can further simplify it, because 4 is really 2 to the second power. So if we have 4 as 2 to the second power, we keep everything else the same, Now we can say that if I have 2 to the second power, and that's the second power, this is a situation where you multiply those exponents. So we can rewrite this all as the cube root of 2 to the fourth power, and that's choice D. Going over to question number 5 now. Which of the following is equivalent to 8 to the 5/3 power? So once again, if we have a to the b over c power, that's the same as the c root of a to the b. And like I said, the thing to remember is that the number that's in the exponent spot is also the number that's on the top of that fraction. So if we have 8 to the 5/3 power, that's the same as the third root of 8 to the 5th. Now once again, it's not one of the answer choices, and the reason why is because 8 is really a power of 2. 8 is really 2 to the third power. So if everything else remains the same, we have 8 as 2 to the third power, and that is to the 5th power. So now we can take the 3 and the 5 and multiply them, and we have the cube root of 2 to the 15th. Now that we have that, we can go ahead and move things back into a fractional exponent and say that that's 2 to the 15 over 3 power. And 2 to the 15 over 3, well, 15 over 3 is really 5, so it's simply 2 to the 5th power. So now we need to invoke a different exponent rule. Basically, the number one rule of all exponent rules is to say that if I have a to the b times a to the c, that's a to the b plus c. In other words, if you're multiplying exponents with the same base, you add the actual exponents. The opposite of that rule is saying that if you were to divide a to the b over a to the c, then you're subtracting the exponents, and that would be a to the b minus c power. So we're looking for something equivalent to 2 to the 5th power, and all of these are things that we can subtract. So for instance, choice A is 2 to the 9th over 2 to the 5th, so that's 2 to the 4th. Choice B is 8 minus 4, so once again 2 to the 4th. Choice C, 8 minus 3, so that's 2 to the 5th. And choice D is 2 to the 7 minus 4, so 2 to the 3rd. So we were looking for 2 to the 5th, and we have that in choice C. Now moving on to number 6, we have 4 to the 3/4 power. So if I have 4 to the 3/4, that's the same as saying we have 4 to the 3rd, because the number that's on top is your exponent, and we have the 4th root of that. So to further simplify, we can just basically take this 4, rewrite it as 2 squared, and we still have the 3 that's here and the 4 that's here. Multiplying the 2 times the 3, we have the 4th root of 2 to the 6th. Writing that as a fractional exponent, that's 2 to the 6 over 4. Now the fraction 6 over 4, if we were to divide the top and the bottom by 2, that becomes 2 to the 3/2. So we're getting a little closer to our answer here, but we're still not all the way there. So we've got 2 to the 3/2, and if we were to write that as a radical again, that would be 2 to the 3rd and the square root of that number. Now, by the way, when there's a 2 here, we don't write it, it's invisible. But that is the square root of 8. But to actually make things a little easier, when you have a square root, in other words, a 2 in this spot, even though that number is invisible, we have really the square root of 2 times 2 times 2. And I'm going to go ahead and write the 2 here, although it's really invisible in the way radicals are really written. But that number, that index on the outside, is a very important number because it shows you how to simplify. It basically says that if you have 2 numbers under the radical, they come out as one number. If there were a 3 in this spot right here, then I would have to find 3 numbers under the radical in order to take one out. So now that we took out a 2, we have remaining 2 square root of 2, which is choice B. Going to number 7, we have 25 to the 4/3. So if we rewrite that, that's 25 to the 4th, and the cube root of that number. We can rewrite the 25 as 5 squared, so cube root of 5 squared to the 4th power. 2 times 4 is 8, so it's the cube root of 5 to the 8th power, and that's choice A. So we're done on number 7. Going over to number 8, we have 8 to the 2/3 power, so 8 squared, and the cube root of that. And 8 is really 2 to the 3rd, so we still have the cube root of some number squared, but instead of 8, we'll write 2 to the 3rd. Multiplying the 3 by the 2, we have the cube root of 2 to the 6th. Now, we can go ahead and rewrite this as a fractional exponent. That's 2 to the 6 over 3, which is the same as 2 squared, and that is 4, choice C. Going over to number 9 now. Which of the following is equivalent to x to the 2/3? Well, the rule we've been working with says that this is the same as x squared and the cube root of that, so our answer is A. Going to number 10, which of the following is equivalent to b to the 3/4? Well, that is b to the 3rd, and it's the 4th root of that, so we're looking at choice B. Going over to number 11 now, b to the 4/6, well, that's b to the 4th, and it's the 6th root of that number. So that is actually not one of the answer choices. So going back here, instead of doing it the way we just did, we can say that that 4/6, that's a fraction that simplifies. That's b to the 2/3. Because you can simplify fractions in that exponent spot, just like you can simplify them anywhere else. Now we have b squared, and we have the cube root of that number, which is choice D. Going over to number 12 now. Number 12 says we have some kind of division situation here. Now the rule that we talked about earlier says if you have a to the b over a to the c, you're subtracting, so that's a to the b minus c. And this is no different. We have b squared right here and c squared right here, so that'll simplify to x to the b squared minus c squared equals x to the 25. This is a very important moment in exponents that you want to get used to. You have the bases are equal, the expressions are equal, and that means that the exponents have to also be equal. So from here we can say b squared minus c squared equals 25. Another thing that's important on this question is to notice that this thing we're highlighting in purple here, that's a very important mathematical concept that you want to be really good at in order to succeed on the SAT. It's the difference of squares. And a difference of squares will have a perfect square, another perfect square, and a minus sign in between. That's why it's a difference of 2 perfect squares. And we're supposed to know that when you identify a difference of squares, it factors to the square root of the first and the second, repeated twice, so b plus c and b minus c, so with the plus sign and a minus sign. So we replace the difference of squares with the factored form of the same difference of squares, and that equals 25. Now the question told us, it didn't seem necessary at the time, but now it does, b plus c equals 5 times b minus c equals 25. And we can go ahead and divide both sides by 5, so b minus c equals 5. So what's the value of b minus c? 5. Going over to number 13, same concept. This thing can be simplified to x to the y fourth minus z fourth. And that equals x to the negative 9. So since the bases are equal and the expressions are equal, we can say the exponents are equal. Y to the 4th minus z to the 4th equals negative 9. Once again, right here. This is a difference of squares. The square root of y to the fourth is y squared. The square root of the z to the fourth is z squared. So this will factor to y squared plus z squared, y squared minus z squared. And we can substitute in this green expression, which says that y squared minus z squared is equal to 3. So we can rewrite everything and say y squared plus z squared times 3 equals negative 9. Divide both sides by 3. Y squared plus z squared equals negative 3. And that's our answer, choice B. Now going over to number 14, we have 16 to the a and 2 to the b. Now this expression would be a difficult one if we didn't notice that 16 is a power of 2. 16 is really 2 to the fourth power, and that's to the a. And on the bottom we have 2 to the b. Simplifying this situation right here, we can say this is 2 to the 4a over 2 to the b. And using our subtraction rule, that's 2 to the 4a minus b. Now we can go ahead and use this piece of information and substitute in for a. So we have 2 to the 4b minus 5 over 4 minus b. And what we have here is a 4 on the outside and a 4 on the inside. So that's like 4 over 1 times 1 over 4. In other words, that cancels, leaving us with 2 to the b minus 5, pardon my sloppy 5 there, minus b. Now we've got b minus b, so that cancels away and leaves us with 2 to the negative 5th. Now what is a negative exponent? It tells us that whatever we're dealing with is on the wrong side of the fraction. So this is really 2 to the negative 5 all over 1, but that 2 to the negative 5 is on the wrong side of the fraction. So if we move it to the bottom, we make the exponent positive, and that leaves nothing but the invisible number 1 on the top. However, we didn't even need to go to that length because the answer was 2 to the negative 5th. Going over to number 15, we're being asked about 81 to the x over 3 to the y. Now 81, that's really 3 to the fourth power to the x over 3 to the y. Simplify it a little, 3 to the 4x over 3 to the y, and use our subtraction rule, that's 3 to the 4x minus y. Now we can go ahead and say that we're going to substitute in for x what x is equal to. So we have 3 to the 4 times y over 4 minus 1/2 minus y. So we have a 4 that we can distribute in to this expression. So that's just plain distribution. 4 times that yellow expression, and that gives us 3 to the y minus 2. If you were distributing 4 into that yellow expression, and we had the minus y that was on the outside, that leaves us with y minus y, and so our answer is 3 to the minus 2 power, which is choice A. Going over to number 16, 32 to the x over 2 to the y. So 32 is 2 to the 5th, and that's to the x over 2 to the y. So now we're multiplying the 5 and the x, so 2 to the 5x over 2 to the y. And x is equal to y over 5 minus 2, so that's 2 to the 5 times y over 5 minus 2 all over 2 to the y. So if we go ahead and just multiply first, since we happen to be here anyway, that's 2 to the y minus 10 all over 2 to the y. And now we can subtract. This is all 2 to the y minus 10 minus y. And here we have y minus y. So the answer is 2 to the negative 10, which is the same as choice C. Moving on to number 17, we can go ahead and write both of these expressions of x as fractional exponents. So this is x to the 4/3 times x to the 7/6 equals x to the b. And this is, like I said before, kind of exponent rule number 1, says that in this situation you're supposed to add. But we can't really add until we have the same denominator, so we're going to multiply this by 2/2, and so that gives us x to the 8/6 times x to the 7/6 equals x to the b. 8/6 plus 7/6 is 15/6, and we're supposed to add there, so that's x to the 15/6 equals x to the b, and therefore b equals 15/6. Going over to number 18 now, we're going to go ahead and write both of these radicals as fractional exponents. So we have x to the 7/3 times x to the 2/5, and we're going to have to add those fractions. So in order to add them, we need the same denominator. So we can multiply this one by 5/5 and this one by 3/3. So for the first exponent of x, we have x to the 35/15 and x to the 6/15 equals x to the y. 35 plus 6 is 41, so we have x to the 41/15 equals x to the y, and y equals 41/15. Going over to number 19 now, rewriting with the fractional exponents, a to the 3/4 and a to the 2/7 equals a to the b. We're going to need to add these two fractions, so let's get the same denominator, multiply by 7/7 right here and by 4/4 right here. Now we have a to the 21/28 and a to the 8/28 equals a to the b. 21 plus 8 is 29, so we have a to the 29/28 equals a to the b. Therefore, b equals 29/28, and that's choice D. Okay, so we just finished question 19. Now we're going over to question 20. Okay, so here, this 1/5 out here means that we would have to multiply all the exponents inside of that parentheses by 1/5. So 3 times 1/5 is 3/5. 4 times 1/5 is 4/5. And same thing for the next one. X to the 3 times 1/6, which is 3/6, which is really 1/2. And y to the 4th, so 4 times 1/6 is 4/6, which is really simplified to 2/3, equals all that stuff on the right hand side. And we need to combine these x's as well as these y's. So we're going to need a lot of denominators. We can go ahead and multiply the 3/5 and 1/2 by opposite numbers. So the 3/5 by 2/2 and the 1/2 by 5/5. So for the x's, we're going to have x to the 6/10 and x to the 5/10. And for the y's, we're going to multiply by 3 and by 5. So this one by 3/3 and this one by 5/5. So that's going to give us y to the 12/15 and the other y to the 10/15 equals all this stuff on the right hand side. Now we can go ahead and take these x's and add those exponents. That's going to be x to the 11/10, and we can take these y's and add those exponents. That's going to be y to the 22/15 equals x to the 9/10, y to the x to the a/10, not 9/10, so this needs to be changed. Sometimes you have to understand your own handwriting when you do this stuff. And y to the b over 15. So we've got some stuff that matches now. 11 over 10 is in the same spot as a over 10. So we just found out that a equals 11. And we can also say that 22 over 15 is in the same spot as b over 15. So we just discovered that b is 22. The question is asking us what's b minus a. That's 22 minus 11, and the answer is 11. Going over to number 21, we can go ahead and multiply the exponents in that parentheses by 1/3. So we've got x to the 5/3, y to the 4/3. Multiply the other exponents by 1/4. So we've got x to the 6/4, y to the 7/4 equals all the stuff on the right. And now we need to combine these x's. So we need the same denominator. And we need to combine the y, so we need same denominators for those. So we can multiply the first x by 4 over 4 and the second one by 3 over 3. And we can multiply the first y by 4 over 4 to take from the other expression of y, and the other one by 3 over 3. So now we're going to have, if we take this one here, we'll have x to the 20 over 12, and putting this one next to it, x to the 18 over 12. And then if we take that y, that's y to the 16 over 12, and y to the 21 over 12. So that'll give us x, we have to add those two x's, so 38 over 12, and y to the 37 over 12. And the question is asking us, what's the value of b minus a? Well, this was all set equal to x to the a over 6, y to the b over 12. So these two things match so perfectly that we already know that b is going to be 37. However, for the a, we need to do some simplifying. 38 over 12, both of those divide by 2, so this will be 19 over 6. So now we've got 19 over 6 matching with a over 6, and we just discovered that a is 19. What's the value of b minus a? It's 37 minus 19. Okay, and that will give us 37 minus 19. So that's choice D. Going over to number 22, the same idea, and this I think will be our last problem here. We're going to multiply everything in here by 1/2, so that'll be 3/4 times 1/2, which is 3/8, 5/6 times 1/2, which is 5/12, and now everything in this parentheses multiply by 6, so we'll have x to the 6/8, which is the same as 3/4, by the way, and y to the 6/3, which is 2. So if we look at these two x's, we can see that we've got a denominator of 4 and a denominator of 8. So we can simply multiply this one by 2 over 2 and get the same denominator. That'll give us x to the 3/8 and x to the 6/8. And now we can look at this y right here. We've got y to the 5/12 and y to the 2 over 1. So this 2 over 1, we can multiply by 12 over 12, and that'll give us y to the 24 over 12 right there. And here we had y to the 5 over 12. So for the red x's, now we have x to the, well, we can add 3/8 and 6/8, so that's 9/8. And for the y's, we have 5/12 and 24/12, so 5 plus 24 is 29 over 12. And that was all equal to x to the a over 8, y to the 29 over 12. So we have 9/8 in the spot where we have a over 8. So we just figured out that a equals 9. We have 29/12 in the spot where we had b over 12 right here. This was supposed to be a b. So we know that b is 29. The question is asking us what's b minus a. It's 29 minus 9, and the answer is 20. Thanks for listening to our lesson on the basic rules of exponents and radicals. Aspire Test Prep is adding new lessons and new videos every day, so stay tuned. Tell all your friends about our free curriculum. It's really helpful to help students through this redesigned SAT, and I think students around the country and around the world can use all the help they can get. And if you enjoy our free resources, you can recommend our online tutoring to your friends and our SAT and ACT classes to the administrators of your high school. If you have any questions, feel free to email us at tutoring@aspiretestprep.com. Thank you very much.